This is our point A. This is our point C. And this is our point D. Okay. So likewise, point A, point C, point D, and point B. And if the ropes are in tension, the rope will look, I will use the rope will look like this in tension, right? It'll be straight line here in tension. It'll be straight line here. So it's doing something. Okay. If the rope are in compression, this is how the structure will look like. Okay. It's like, okay, so this is the rope in compression. When the rope is in compression, it offers no support. Okay, so if you want it to be support, if you see your rope sagging, you have not tension enough yet. Okay, it's a waste of time. Okay, whether you have the rope there or you don't have the rope there, the effect is going to be the same. Are we clear? So the ropes has to be in tension. Okay, that is more important to note. Now, we are now going to focus how this rope is behaving. And we are going to look at two different planes now. Okay, we're going to look at two different planes. Okay. So the plane that I want you guys to watch now. So now the next few graph that or next few figure we're going to draw, we are going to specify the ropes or rope BC and BD are in tension. Okay. So the first thing I'm going to draw on the XZ plane. Okay. On the XZ plane. So on the XZ plane, if we look at PCR XZ, this is going to be pi squared, okay, E IY over LE squared. What this LE is, don't know yet. It's okay not to know for now. Okay, we don't know yet. So I'm going to sketch this now. Yeah, I'm going to sketch this now. Okay. So our transformation X, Z, rotation, the Y. Okay, that's why it's IYY. And then we have a load down here. We have I'll draw centroid. Okay. Then I'm going to use a different color now. And this color represents the action on the rope, like what we had before. Okay. And we know that the rope are in tension. So we put the rope in tension. Okay. On the other side, it's also in tension. So this is our rope BC. This is our rope BD. And both are in tension. At point A, right, we have a reaction heading this direction. And the rope is inducing a BDX and is also inducing a BDZ. On the other side, you have two components also. You have your BCX and you have BCZ. Okay. So what the ropes are doing, right? What the ropes are doing is it is preventing the structure can still go up and down. Okay, the structure can still go up and down. The P, right? The P over here can still make the rope go down because if you look BDZ and BCZ is also going downwards. Okay, but in our analysis, we don't need to consider that is going. We are going to neglect the tension in the cables. Okay. However, BDZ and BCZ are preventing moving the structure from moving along the what? X-axis. Okay. So for this case, at point A, M at point A is equal to what? 0. But it's preventing the structure from moving left and right. So this N is what? Pin. Okay. So if you go back go back earlier in I was recalling, okay, our quick revision. Remember what I said? There is this resistance. Okay. Prevent it going from where? Left and right. That's what the rope is doing. Preventing it from left and right. So when that's the case, what we have over here, this is P. Okay. So we have one end pin. The other end is what? Fixed. So we have one end pin, the other one is fixed. So if we go over here, one end pin and one end fixed, okay? Then we come back over here. And then we look at this diagram over here. Right? One end pin, one end fixed. So therefore, we know that LE is equal to 0.7 L. Okay. Now let's look at the other orientation now. Okay, again, buckling can occur in two planes. Okay, in two planes. So now we look at the other plane now. So the other plane now I want to look at is we are going to look at our YZ plane. Okay, we are now going to look at our YZ plane. So now if we view our YZ plane, okay, so this is our Z. And this is our Y. So now we still have this structure over here. Okay, we still have this structure over here. So this is our point A. Okay, this N is fixed. Okay. And I'm going to draw the green line. Okay. I'm now going to draw a green line. And now, if we look at, we have forces still, right? So we know that this is our P. You will ask me, Eugene, where is the axis of the rope now? The axis of the rope, which I will draw slightly thicker, is also in line with our green line. Okay, so I'm going to draw a force down here, coming down. Right? This will be, this force is our what? BDZ. And this force is also our BCZ. Okay? And then coming towards us, there's a force coming towards us or away from us. There's a force coming towards us or away from us. This is our BDX. And this is our BCX. Okay? So, question to all of you. Okay? What is preventing the structure from moving left to right? Can someone type something? Is there anything preventing the structure going left to right? Is there any forces they can see preventing the structure going left to right? Anyone? I hope you are still awake, you know. Any forces preventing going left and right? I don't see anyone typing, oh God. So, no, yeah, you are absolutely right. So when that's the case, if you have nothing preventing it going left and right, the buckling will go this way now. So when this is the case, one end is free, the other end is fixed. No doubt we have the rope. Can you see that, right? No doubt we have the rope, right? So by viewing at two different axes, you see different things. That's why I'm highlighting that the rope has to be in tension, right? So once you see that, you know how to draw the components. After drawing the components, you say, yeah, there's nothing preventing the structure going left and right if you look at a different plane. So now what you see over here now, you have one end fixed and the other end is free. Okay. Okay. So when that's the case, what we see is LE is equal to 2L now. Okay. Okay. So if we were to write out, I do apologize, I did not write up the formula for this case. So for this case, we have PCR in the YZ, and this is equal to pi squared EIX over LE squared. Okay. And earlier we have defined our IX. So this one we use IX, and this one you use IY. So IY, as we can see on the table before, is equal to 11.4. Okay. And the other one, IX, is equal to 118. Again, we have the same problem, right? So this is good for buckling. This is no good for buckling. When you compare left and right, this is no good for buckling. This is good for buckling. Okay. So I can't tell, or we can't tell, which axis will buckle first, or which is stronger and which is not. We can't. So what we have to do now is we have to calculate the equivalent length. Okay, we have to calculate our equivalent length. So we are given. Okay, we are given. Okay, so let's recap. We are given that P is equal to 15 times 10 to the power 3. and we are given factor of safety is equal to 2.2. Okay, so from here, we can calculate our PCR is equal to P PCR is equal to factor of safety multiplied by our P. Okay, multiplied by our P. So for this case, this will be equal to 2.2 times by 15 times 10 to the power 3. So 2.2. So it's equal to 33 times 10